Okay, today's stuff, it's quite a bit more challenging than what we were doing. The goal is much the same, but we're going to be factoring trinomials have a leading coefficient not equal to 1. An example of that is right here below. This 15x squared means that in the parentheses, yes, I'll have an x in each parentheses, but it won't just be a single x. It might be 3x and 5x. It might be 15x and 1x. There's a lot of choices I have to go through. So I will show you two different ways in which to do this. Okay. The first one is what we call guess and check. 15 has only a few factors, and so it's still reasonable to try and guess. I can go with 1 and 15, and 3 and 5. And those are my only choices for 15x squared. So I can try to work with those numbers, and then 2 only has factors of 1 and 2, and there's no guarantee which one's going to be positive and negative. I know that my signs will be different, but I don't know which is which. So because of that, I will leave the signs alone for the very end. So I'm just going to guess. Most of the time, things like 1 and 15 will not be the right answer. So I'll start with 3x and 5x. So 3x and 5x. And again, if I multiply these through FOIL, I would get 15x squared. That's good. Next, I'm going to go in and deal with the 2. And really, this is called guessing and checking. I'm going to try the 2 in one spot, maybe try it in another, and see which one works. For instance, if I try 2 here and 1 here, the inner and outer of FOIL would give me 5x and give me 6x. If I add them, I get 11. If I subtract them, I get 1. Neither of those produces the 7 that I'm hoping for. So I've done something wrong. So I'll erase those. And I'm going to try again. So we'll try to put maybe the 2 here and the 1 here. 2 times 5, that's 10x. 3 times 1, that's 3x. Now I have to determine which one do I want positive, which one do I want negative. Well, the middle term is positive, so I want this 10 to be positive and the 3 to be negative, because the 10's bigger, so it should match this guy's sign. Well, the 10 was made by the 5 and the 2. So I need to put the positive with the 2 and the negative with the 1. This is the factored version of this. That guessing and checking wasn't too bad. And if that feels like something you can try to reproduce, absolutely go for it 100%. However, if that seemed like I was pulling a rabbit out of a hat, there is another way. It's not always easier, but it is possible. And what I'm going to do is just over here, I'm going to start the process. I'll start with 15x squared plus 7x minus 2. What I'm going to do is I'm going to multiply the two ends together. I would get negative 30. I'm going to take that negative 30 and split it into factors that give me positive 7. And so I'll try things like 1 and 30, 2 and 15, 3 and 10, and I think I've got 5 and 6. The signs are going to be different, and the big one should be positive, so I'll make these negatives real quick. This is a little more similar to what we were doing before, but there will be some significant differences. And if this doesn't make sense, I want you to stick to the guess and check method. So what I'm going to do is I will pick the negative 3 and 10, but what I'm going to do is I'm actually going to take the 7x out and replace it with these two pieces. So I'll put 15x squared minus 3x plus 10x minus 2. Now, some of you may be really surprised and don't know what's going on right now. What's been happening is I took the negative 3x and the 10x and I replaced 7x with them. If I add these two together, I still get the 7x. The magic trick comes in just a minute. With a plus sign in the middle, I can slip parentheses around the first two and around the last two. The reason I do that is I want to group them. This is called factoring by grouping. I want to separate them and pull out what's common. Well, what do these two have in common? They share a 3 and an x. That would leave me with 5x, okay, minus 1. And we can check by distribution. 3 times 5 is 15, x times x is x squared. 3x times negative 1 is negative 3x. Plus, what do these two have in common? A 2. And what would be left over? 5x minus 1. Do you see how these two parentheses line up identically to one another? That means that that is one of my parentheses, one of my factors. The other factor is made up with what's on the outside of the parentheses. I see a 3x, I see a plus 2, and there is the exact same answer as over here. They are the same. So both methods will get me there. I'm going to focus on this. When I'm in class with you, I will focus on doing a little bit of both. But I think this is my preferred method, but this works as well if you feel comfortable with it. It does take a couple extra steps and some understanding. Let's take some look at some of the problems you'll face today in your assignment. I'm looking here. There aren't a lot of options with the 3, which makes it nice for guessing and checking. So I'm going to put 3n and n, because 3n times n, or 1n, is 3n squared. Now, if the signs are identical, like this tells me, then I can put them in right away, because it won't matter which one goes where. They're the same. This tells me that they're both positive, so plus, plus. And then I want to put factors of 4 down. Well, 4 factors is 1 and 4, or 2 and 2. I can guess and check all I want. Let's go ahead and do the 1 and 4. I put 1 and 4 here. I get 1n and 12n. That gives me 13n. That's wrong. So I'm going to come back, my eraser. Let's take those out. Let's try a different combination. And I like to stick with the numbers I've used until I'm sure that they're gone, that they're not useful to me. So I'm going to do this. I'm going to switch the 4 and the 1 places. This gives me 4n. The other one gives me 3n. That total is 7n. And this is my solution. Guessing and checking is not a bad idea as long as this number doesn't have a lot of options. If this number factors, if it's a number like, let's say, 48. 48 has so many factors that it would take me forever to go through them all. And that makes the other method maybe a little bit more structured. When you get to problem 24, you're in a section where it says factoring monomials first. Monomial, okay, this means one term. Okay, so we're going to factor out a single term first, and then we'll look at it again. And that we did a little bit of this with their last assignment. We want to ask, what do these have in common? Because right away, it does not look like a difference of squares, and so I'm not sure what to do. But it looks like they're both even numbers, both divisible by 2. So I'm going to pull a 2 out. I'll be left with 16 v squared minus 1. Okay. Now this 2 is just going to hang out along the way for the ride. I'm not going to use it again. I'm not going to touch it. Just bring it down. Now, is 16 a perfect square? Yes. Is v squared a perfect square? Yes. Is 1 a perfect square? Yes, it has a square root of 1. And this is a subtraction. So this is a difference of squares. Okay? So with that in mind, we're going to try to separate this as a difference of squares. I'll set up my 2 parentheses. Again, that 2 just hangs out there. What's the square root of 16? 4. What's the square root of v squared? V. I know the signs will be different, so plus and minus. What's the square root of 1? 1 and 1. And I'm done. That was it. Not all that bad. Next, and this is going to be the last problem that we look at on this assignment together on here. We'll have more problems we'll go over in class. And again, if you haven't got all the help you need, come in, we'll figure it out. Don't get overwhelmed, but do everything you can. Watch these videos over and over again if you have to. Here, they're asking us to find the zeros again. That means that this value of y is going to be 0. Okay, we're going to put a 0 there. So 0 equals 18x squared minus 6x minus 4. And this is a good example of a problem that might not be that easy to use guess and check. Because if we think about 18, it has factors of 1 and 18, 2 and 9, 3 and 6. And I think that that's it. But that's 6 choices. And there could be quite a few. And with the 4 having a few choices itself, this could take a while. We're going to try to just throw some numbers in there. If we can't get it, we can jump to the other method. But I'm looking, 6 is not a very big number, so I'm thinking maybe 2 and 9. Let's give 2 and 9 a shot. If it doesn't work, we'll switch them out. So 2x, 9x. I don't know the signs. I'm going to leave it alone because they're different. This tells me they're different. So I'm going to take the factors of 4, which are 1 and 4, or 2 and 2. Let's grab the 1 and the 4. Okay. If I put the 1 here and the 4 here, okay, I'll get 9x and 8x. That does not work, so I'll erase it. I can switch them places. Put the 4 here and the 1 here, but this gives me 36 and 2. There's no way that's going to work. And again, if you're unsure of where I'm getting the two numbers from, it's from the multiplication of the inner and outer from FOIL. You know, middle, it's these two that I'm doing. So 1 and 4 did not work with 2 and 9. It might work with a different combination. 2 and 2, it won't matter where I put them, but I'll get 18 and 4. 18, 4. That gives me 22. Not a good answer. Or it would give me 14. Still not a good answer. So that tells me that 9x and 2x are not going to work. Again, this is guessing and checking. No easy way to do it. Another one, let's stick with the 3 and 6 maybe. So we'll go 3x, 6x. Let's go ahead and go with the 4. Let's go 4 here, 1 here. Here I get 6x. There I get 12x. If I add them, I get 18. But if I subtract, I could get 6. Now I want a negative 6, which means the bigger number needs to be negative. So negative 12. That means I need the 4 or the 3 to be negative to create that negative number. I can make the 4 negative and the 1 positive. Great. Now I've got it factored. But this doesn't mean I'm done because we have that equal sign that tells me they want the answer. Now on this first one, okay, what I'm going to do is I'm going to pull it out, say 3x plus 1 equals 0. What do I put in? It's complicated because of this 3. So I'll work through the first one. We subtract 1. We get 3x equals negative 1. Divide by 3. And x could equal negative 1/3. That is a reasonable, good choice. That will give me 0 in this equation. The second one, I want to try first to create the fraction without having to do all the work. So what I'll notice is, just like before, the sign is going to change. It was a positive, now it's negative. Over here it starts out negative. I'm expecting this to be a positive fraction with 4 on top. Just like the 1 ended up on top, the 4 should end up on top with the coefficient of x ending up in the denominator. Now 4 over 6 we know reduces to 2/3. Okay, so 2/3 is my other choice. If that was too much, write it down. 6x minus 4 equals 0. Add 4. 6x equals 4. Divide by 6. And by 6. This means that x could equal 4 over 6, which is 2 over 3. Okay. So when we get to these more complex, we're going to make mistakes. We're going to have to guess and check over and over again, but hopefully we can get comfortable with getting a number sense and finding the right way. If this is something you struggled with, we will work with this a little bit more. If there's a few of you who really like it, I'll work with you independently and try to get you mastery on that so that you know what you're doing. But hopefully that helps, and good luck. We'll see you next time.